Hi guys, in this episode of Shri series, we're going to be talking about the difference between parallel and perpendicular lines. So again, we're still on the topic of linear graphs, all right? So what I wanted to do was to give you a bit of a theoretical explanation to what parallel and perpendicular lines are. What's the difference between the two? All right, how do you know that two lines are parallel? By either looking at a graph or through an equation. How do you know if a line or two pairs of lines are perpendicular, and how can you prove that they are perpendicular using equations of a straight line? All right, so before I go any further, let's talk about an equation of a straight line. In the previous videos, I did mention to you that equation of a straight line is equal to y equals mx plus c. So in other words, that's the formula for every equation of a straight line. All right, if you look at the previous videos where we talked about finding the equation of a straight line, m stands for your gradient, and we know that gradient is y2 minus y1 over x2 minus x1. So we've done some calculations on that. y2 minus y1 minus x2 minus x1. That is a formula for calculating your gradient. And c is your y-intercept. All right, so y-intercept from our basic understanding is the point on a graph where the line cuts or intersects the y-axis. And using the rule of your opposite, in your y-intercept, the x-coordinate is 0. All right, so that's a bit of basic understanding. The reason why I wanted to touch base on gradient again is that is what determines if lines are parallel or perpendicular. The concept is in the gradient. All right, now before I look into the gradient, let's draw a simple graph here, just a sketch. All right, we've got two simple graphs here. All right, let's say A and B. All right, now suppose I draw a straight line like that. We know that's an equation of a straight line, or that is a straight line of the form y equals mx plus c. All right, how do we know if another line is parallel? All right, so parallel, think of roads. All right, you've got one side of the road and the other side of the road. They are parallel because they don't meet. So parallel lines don't meet. So think of a road, one side of a road and the other side of the road, they don't meet or intersect. All right, so if you look at a graph like graph A and you want to find out if a line is parallel, think of something like that. All right, now suppose, let's call that m. The gradient of that line is m1. Let's say the gradient of that line is m2. All right, so two lines are parallel when they don't meet. So that's a simple illustration of two straight lines that don't meet and are therefore parallel. Now here's the trick. With parallel lines, the gradients are the same. So what do I mean by that? The gradients in parallel lines will always be the same. Now imagine the gradient of this line is m1. So let's just hypothetically say that the gradient of that line is m1 and the gradient of that line is m2. Therefore, m1 is equal to m2 in parallel lines. So in other words, parallel lines have the same gradient. So for example, if let's say the gradient of m1 in this case is 1 and m2 is parallel, therefore the gradient of m2 is 1 as well. So in a nutshell, parallel lines have the same gradient. So this is how parallel lines are represented on a graph. You've got one line here and you've got another line here, and based on the definition, they don't meet. All right, so that tells you that parallel lines will have the same gradient. So in other words, m1 equals m2. If m1 is equal to 2, then m2 will be equal to 2. Suppose m1 is negative 1, then m2 is negative 1 as well. So that's how you understand parallel lines have the same gradient. Now, let's look at perpendicular. Now, when we talk about triangles, for example, we fondly refer to as a height as a perpendicular height. All right. So when you think of perpendicular, you think of 90 degrees. All right. when we talk about geometry, for example, when we talk about Pythagoras theorem, or when we talk about measurements and we're looking at the height, like for a triangle, we refer to as perpendicular. And this is a sign for perpendicular. So when you think of the word perpendicular, you think of the 90-degree angle. All right. So perpendicular lines in a nutshell are two lines that meet at right angles. So in this case, 90 degrees. All right. So if you look at this line here, that line and that line are meeting at right angles. So these are referred to as perpendicular lines. All right. Now in linear graphs, I'll use a different color. Perpendicular lines are exactly the same. They meet at 90 degrees. They meet at right angles. So suppose we've got a line here. So let me just sketch. That's a blue line right there. And how do I know that this line and another line are perpendicular? Suppose you've got this line here, and I'm going to use another color here, and here's another line. All right, so suppose we've got this line and you've got this line. So imagine that's M1 and this is M2. And they meet at right angles. So M1 and M2 are meeting at right angles, pretty much similar to this illustration. So in terms of gradients, how do you know that two lines are perpendicular? All right. If you remember, in parallel, the gradients in parallel lines are equal. So in other words, M1 is equal to M2. All right. How do we work out perpendicular lines? Now imagine we've got this line here and the gradient is M1, and we've got another line here and the gradient's M2. In perpendicular lines, the product of the gradients is -1. What do I mean by that? So when we've got M1, imagine that's the gradient M1, and we've got M2. When we times them, as you know, product means times. When you times them, the product or the answer will be -1. So in perpendicular lines, M1 times M2 equals -1, or M1, M2 equals -1. So in other words, two lines are perpendicular when the product of their gradients is -1. All right. So that's how you differentiate between parallel and perpendicular lines. All right. Think of parallel. M1 and M2 are equal. So the gradient of M1 is equal to the gradient of M2. This is how you represent them graphically. I wanted you guys to see visually what parallel lines look like. So you see they don't meet. All right. So their gradients are the same. So M1 is equal to M2. In perpendicular, the lines actually meet, but they meet at right angles. Perpendicular means 90 degrees, all right? So perpendicular lines in linear graphs means two lines that meet at 90 degrees. They meet at right angles. And therefore, the product of their gradients, so M1 and M2 equals -1. So for example, let's think of something. Say the gradient of M1 is 2 and the gradient of M2 is -1/2, and I want to find out if M1 and M2 are perpendicular. All right, they're definitely not parallel because the gradients are not the same, but let's multiply them. 2 times -1/2, and that is -1. All right, so that's how you work out if two lines are perpendicular. The product of their gradient equals -1. So I wanted to illustrate this video to give you a theoretical explanation on the differences between parallel and perpendicular lines. In the next video, we're going to be solving questions to prove whether two equations are parallel or straight lines using y equals mx plus c. So in a nutshell, just to summarize, parallel lines have the same gradient. M1 equals M2. Perpendicular lines, the product of their gradient is -1. So M1 times M2 equals -1. Thank you guys for listening. Bye now.